Right, the examiner wants you to know about the uplands and the lowlands of Britain. What we're going to be looking at today is the uplands. In particular, we're going to give what the examiner wants, which is how tectonics, how geology, and how glacial processes have affected the British uplands. So by the end of this lesson, hopefully be able to answer the question on the screen there using most of the keywords, all of the keywords, that'd be great. So let's start. Carboniferous period, 300 million years ago, the area that will become Britain's upland areas, the areas that will become, let's say, the Pennines, is underwater in a nice warm tropical sea. Loads of coral growing at the bottom, loads of plankton in the sea. Unfortunately, the plankton dies. Unfortunately, the coral dies. More coral grows on top of the dead coral. Plankton settles down to the bottom of the ocean as it dies. And we're developing a massive, thick sedimentary rock. That rock is getting thicker and thicker as time goes on. We've seen in the previous video. Now, tectonically speaking, this landmass is now being pushed further north. It's being pushed towards 50 degrees north of the equator. The sea above it is cooling down. The sea above it is now shallower. So the sediment that's settling out of the sea now is coarse sand, basically because of all the rivers dumping their load into the ocean. Still, geologically speaking now, and tectonically, migrating further north, and now the sediment being deposited at the bottom of this really quite shallow sea is from estuaries, rivers eroding the land, dumping that load out to sea, and that is now what is making those thick sedimentary rocks. Tectonically speaking now, the land is going to be pushed up. Therefore, geologically, that sedimentary rock is going to become metamorphosed. It's going to become physically harder. And so the sea is now completely gone. What was below the ocean is now being forced up, up, up because of tectonics, plate tectonics. So we're sort of learning a bit about what the examiner wants. Now, my drawing here is showing how the rocks have become consolidated. All the water's dried out, most of the water's dried out, and we've now got 3 layers of quite distinctive rock. This is key for what you need to give the examiner for the geology. Millstone grit is the youngest, but it's also physically hardest. It is the most resistant. At the very, very bottom, you've got the Great Scar limestone, which is all that stuff made by the coral. And in between, you've got quite soft sand and shales, which were deposited when the ocean was reasonably shallow. So, what's going to happen? Well, it's up high, it's precipitating as rain. Rain will turn into rivers, and so even though the millstone grit is physically hard, it's eroding. Can you see I've kind of made it erode there? That erosion should be classic V-shaped valleys, and it is, okay? Vertical erosion, we're up high, plenty of potential energy for the rivers. However, a little bit, if you've ever done your waterfalls, alternating layers of harder and softer, physically hard, physically soft, resistant, less resistant rock, you're going to get quicker, more rapid erosion when the rivers erode the shales and the sandstones. However, let's go on to geology. Geology, the world is going into an ice age. So the precipitation now has changed. Can you see my blue lines? It's snow. The snow is not melting in spring, so we're getting snow on snow on snow on snow. Snow is getting compacted. The ice is basically turning into ice. The air is pushed out, and we're getting glaciers. The glaciers will develop in what were the V-shaped valleys, cut out by the rivers, and now the glacier is sliding down those valleys, turning them into U-shaped valleys, okay, plucking and eroding as they go, and making them absolutely huge, these U-shaped valleys. So this goes on for a while, alternating actually between rivers, valleys, as geologically speaking, the world heated up, cooled down, heated up. So we've got what we're getting to, a big, big U-shaped valley full of ice. But then the last time it melted, it's not returned to our ice. Our ice age ended. My drawing should show the blue lines disappearing, leaving us with a massive U-shaped valley and eroded upland areas. The bits of millstone that are still there are now the highest bits on the land. They're physically hard. As the glacier melted, it's left behind some boulder clay. This is quite a strange rock. Some of the sediments might be really fine, where the rock was scratching across other rock, making almost like a talcum powder. Others might be huge boulders just dumped behind because they were on top or within the ice column, not scratching anything. However, it's warmed up, so the precipitation's back as rain. Rain, it means rivers. We're up high, so rivers means erosion, vertical erosion, and that is now being transported and then deposited on the floodplain. It's not the floodplain from the river, it's the floodplain of the wide U-shaped valley bottom. So that's giving us alluvium. Alluvium is that lovely soil that farmers can grow their crops in, deposited by the rivers quite recently. So now then, we're getting towards the geological cross-section your examiner wants you to be able to draw. Let's just hit the pause button. You've got the tectonics. Tectonically, this landmass was underwater in the tropics. Now it's migrated further north and it's being pushed up high. You've got the geology. It was underwater, sediments accumulating. That's turned into rock consolidation. And you've got the geology alternating ice age, not ice age, and that's given us the wide U-shaped valley. Then you've got glacial processes giving us the U-shaped valley and that boulder clay at the bottom. So now we're getting to the skill, and this is an absolute classic thing to draw. You've got effectively a mirror image. The U-shaped valley in the middle, please remember the boulder clay and then the alluvium above it. Either side, two small mountains, sometimes called fells, often made of this harder, physically harder, resistant rock called millstone grit. Right, I'm hoping that's been useful.